Hello, welcome to TechWebDots. Today I'm going to start the Docker step by step for beginner series, and this is the very first session of the series. So let's go ahead to see what are the topics that I'm going to cover in this series. So about Docker, I'm going to cover all these topics, which includes Docker networking, the storage, installation, and the basic concepts like container, images, Docker file, and why we need Docker, right? So all these topics will be covered in my upcoming subsequent sessions. Okay, so in this session especially, I will cover why we need Docker and what challenges Docker solved for us. Okay, let's start without wasting time. So before Docker, what was the problems that we faced in the software development, right? But if you are here, then you must already aware about the one liner about Docker is a containerization platform which is used to develop, ship, and run containers. But what was happening before containers or before Docker? Before Docker, several key challenges in the software development and deployment phase. So traditionally, we generally use one hardware and a operating system on top of it, and on top of it we install the required web server, we deploy the application, we deploy the DB server and other required libraries to run our application. And then we have further enhancement to VM where we have the hardware, the operating system, and on top of it the hypervisor, which enable the virtualization technique, which gives us the facility to run multiple virtual machines on the same hardware. And similarly, we have the web server, application, and DB and other stuff, other required libraries to run the application. But what was the challenges? It works on my machine syndrome, means traditionally developers often faced issue where an application functioned perfectly in their local environment but failed in testing or production. So there was always conflict between testing team and the developer team. Second challenge, dependency conflict. Different applications often require conflicting version of libraries or software, means when you are running the things locally, those are different, and when you are deploying the same set of libraries and other things when they goes to the server, because of the version conflict, the issues arise very frequently. Inconsistent environment, setting up identical development, testing, or production environment can be complex and time consuming because we have to map each and every small thing, the required memory, required versions. We have to manage everything. Slow deployment. Deploying application traditionally involve complex configuration and installation procedures, which was time consuming and cumbersome as well. The resource inefficiency. Traditional virtual machines, if you talk about any one of the option, either it is traditional deployment or it is deployment on VM. So traditional virtual machines consume significant resources as each VM includes a full operating system. Yes, whenever you run any virtual machine on a big machine using hypervisor, using virtualization, so you have to install the required operating system on top of it. Only then you can run your application, so that there is a resource inefficiency exists with that approach. Scaling difficulties. Scaling application traditionally involve complex infrastructure management because you have to manage when there is a demand and you have to scale your infra, and when there is a decrease or there is low demand on the service, then you have to decrease the infrastructure. So that difficulties also exist before Docker. Microservice complexities. So challenges in microservice deployment and scaling. Again, microservice concept is completely depend upon each service is working individually, having their own set of libraries, having their own database, having their own application which is completely independent from the other application, but they are related. So there we need separate VMs before Docker we have to use, but that management is very difficult and we have to face many difficulties in the deployment as well. Now, when we have the Docker, right, so it solved many of the problems. So don't worry, we'll discuss in detail, but I just wanted to show you what changed after Docker. So Docker effectively addressed several key challenges in the software development and deployment that we have just seen. Those were the problems, and Docker is the solution for them. And if you see the basic architecture for the Docker containers, it has a hardware, on top of it the operating system, then we have container runtime, or you can say the Docker engine, and on top of it we run our application. We'll discuss the inner components of it as well, but just to see what problems Docker solved for us, it works on my machine syndrome. Now Docker resolved this by packaging all the application and its dependencies into a consistent container. It means you just build container one time and run it anywhere, ensuring it runs the same way across all environments because it contains all the information of its dependencies. Now, dependency conflict. Docker isolate these dependencies within container and preventing conflict and ensuring each application has its required environment. Because of the tracking, because of the whole dependency package, there is no problem of dependency conflict. Inconsistent environment. Docker simplifies this by providing a standardized container format, allowing for consistent environment throughout the software lifecycle. It means the way it is working on the dev environment, in the same way it will work on testing or the production environment. There will be no change. Slow deployment. Docker streamlines this process by providing pre-configured container images that can be quickly deployed, leading to faster release cycles. We will learn about this, what pre-configured container images we are talking about. It is one-time effort if we are creating our own image, or there are many existing pre-built official images as well from Microsoft, from Google, from Nginx. There are different parties. We will discuss about them in the upcoming sessions. So this problem also resolved. Resource inefficiency. Docker containers, on the other hand, shares the host operating system kernel. It means you don't need to install the complete operating system on your machine, resulting in significantly lower resource overhead and higher density. Scaling difficulties. Docker simplifies scaling by allowing for easy creation and deployment of multiple container instances, enabling application to handle increased traffic and demand. Similarly for in lower demand scenario as well. So we can manage it with the Docker Compose, and there are many other orchestration tools available, Docker Swarm, Kubernetes. We will discuss about them as we move ahead in the series. Microservice complexities. So it allows each microservice to be contained and independently deployed, which is a basic need of microservice, and scaled. So that's how Docker container solving all these problems if you are following the Docker container environment. In essence, Docker promotes portability, efficiency, and consistency. It means it can run anywhere with consistent manner and simplifying the software development and deployment process. So I hope with this explanation things are clear. In the next section we will discuss about what Docker is, about its main components. Till then, bye bye.